guys, so our next lesson that we're going to be looking at is lesson 8. My bad. Lesson 9. We are skipping lesson 8, so you do not have to do lesson 8. Let me repeat that. Do not do lesson 8. We're not doing it. So for lesson 9, we are looking at identifying solutions to inequalities within a context. So we're going to be dealing more with those inequalities and looking at those. Most of what you guys are going to look at today, it's all going to be on the screen. You won't be seeing me, my face through this one. So just follow along on the screen as we go through the slides. And then I'll talk a little bit more at the very end. And remember, listen for our key word for the day. Alrighty, so looking at lesson 9, unknowns on a number line. So the number line shows several points. Each are labeled with a letter. So we know where 0 is, but aside from that, we don't necessarily know what A, B, C, E, and F are. We just know E and F are on the positive side, whereas A, B, and C are on the negative side of things. So for the first question, we need to fill in each blank with a letter so that the inequality statements are true. So the first one, something is greater than something. So in looking at this, we have a lot of possibilities, right? Because we know F is the largest thing and A is the smallest. So we could go with F is greater. Sorry, it's slightly complicated to write with this. F is greater than A. That would be one possible solution we could have for this. Now, are there others? Yeah, and my guess is you guys had other ones that you were saying. You could say that F is greater than E, F is greater than D, E is greater than D, F is greater than C, D is greater than C, so on and so forth. There's so many combinations that we could have for this. So long as the number you chose is larger than the second number, or I should say letter, since we don't have actual numbers here, then it's going to be true. Now, the second one is looking at something is smaller than something else. So something is less than something else. So once again, do we have multiple possibilities or multiple possible answers? Yeah, we do, because look, B is pretty small. It's on the negative side. E is on the positive side. So is B smaller than E? Yeah, it is. So B is less than, these are complicated to write. B is less than E. Now, once again, I could have said A is less than B, A is less than C, B is less than C, C is less than D, D is less than E, E is less than F. Those are all possibilities for what we could have done here. There's a lot of room for different possible answers here for what we see, because we're dealing with inequalities and we've got lots of points. So as long as we hold true to the inequalities, so as long as B really is less than E, then we have a true statement. Same with any of the others that you might have come up with that I didn't just write down. So with that being said, Jada says she found 3 different ways to complete the first question correctly. Do you think this is possible? Well, what did we just go through? Yeah, it is possible. We found numerous ways to do just part A. I mean, we had over 6 different ways at least to take and do part A on that one, and we weren't anywhere close to being done with different possibilities. So yes, she is correct. So I'm just going to put a yes here. And reason being is it's all on what values you pick. So if you pick F as the largest thing, well, you've got a lot of different possibilities for what you can do under that. If you pick B as the greater number, once again, you've got a whole bunch of numbers underneath that. Same goes for D, for C, for B. And then same thing is true for part B here. So there's lots of different possibilities. For number 3, we're looking at listing values for each letter on the number line based on its location. Well, we already know D is 0, so we don't have to worry about coming up with that. We can't change that part. It has to remain 0 because that's just holding true. But we know E and B are approximately the same distance. They look to be the same distance from 0 as each other. So they need to be the same amount. So I'm going to say, and this is just giving it values. So this could be, we could say 10, we could say 50, we could have it completely scaled all different ways. So, whoops, and I just wrote the wrong thing in the wrong place. So I'm going to say that B is our -5. Very complicated, right? And E then would be our positive 5. Because remember when we did opposites? Opposites are the same distance from 0 as the other. So negative 5 is 5 units from 0, and positive 5 is 5 units from 0. So they're the same. So if B is negative 5, if we look at C, we know it's got to be pretty close to 0. So let's go ahead and say it's about a negative 2. Would be a good possible choice there. Ooh, 2s are hard. All right, so now we've got F and we've got A. Now, A is definitely way out there. It's a lot further from 0 than what F is. So let's go ahead and put a negative 11 on our A value. It looks to be a little bit more than double of what B is. So double of B would be negative 10. So negative 11 looks to be a good approximation there. And so if A is further from 0 than F is, we know that F is going to be something less than negative 11. And if we look, it looks like E isn't quite doubled on this side. So let's go with F is about 9. So there's a possibility. Now, this is just one possible way of doing that. You did not have to choose those values. You could have had it scaled any way you wanted. That was just one way that we could have taken and labeled those values with numbers. So like I said, we could have had E be 50 and B be negative 50, F be 90, all sorts of different things. So it just depends on how you decided to scale it. So this was just a nice basic, tried to keep it simple when I scaled it. Okay? All right, so the next thing we're looking at now, we have amusement park rides. So we've got different requirements, and we're going to show what that looks like graphing it out. So Priya finds these height requirements for some of the rides at an amusement park. To ride the high bounce, so we've got our high bounce here, we have to be between 55 and 72 inches tall. For the climb-a-thon, we have to be under 60 inches tall. And for the twirl-a-coaster, we have to be 58 inches minimum. So we want to write an inequality for each of the 3 height requirements, use H for the unknown height, and then represent each height requirement on a number line. Now, I'm going to do this on a whiteboard, so I'm not going to use this exact number line here just because that's going to be a little easier for me to try and show you guys than it would be on there. Trust me. Okay, so if we think about our high bounce, it said that we're between 55 and 72 inches tall. So that means our H value, so this is high bounce, we're going to have 2 inequalities because we have a maximum and we have a minimum. We have the tallest we could possibly be, 72, and the smallest we could be, 55. So we're going to say that H has to be greater than 55 and H has to be less than 72. Now, whoops, can't see that. Now, sometimes we take and write inequalities like this all together. You are not required to do that, but that is something that sometimes we see. So I'm going to show you what that looks like. So let me get this turned a little better. There we go. All right, so we could also write this as 55 is less than H is less than 72. There we go. Nope, not yet. There we are. Now you can see it. Sorry about that. Still trying to figure out the proper placement for these boards. Okay, so like I said, I'm expecting this from you. If you are comfortable with this method, that's perfectly fine. But all I'm looking for is you to be able to write the 2 inequalities separate. So that's all the more I expect. So for this, for a number line then, we've got our big long number line. So I'm going to have 80 here and 50 here. It's going to keep going on either direction. Now, what we're looking at is we're going to have endpoints. So 50, 1, 2, 3, 4, 55. So here's our 55. Now, in this, because it said between 55 and 72 inches tall, does that mean that we can be 55 and 72 inches tall, or does it mean we actually have to be between those 2 values? Well, it's a little unclear based on how it's saying. So with the way I wrote it, it's saying we have to be more than 55. If we're just 55 inches tall, doesn't count. And same thing with 72. If we're exactly 72 inches tall, nope, we're too tall, we can't write it. We could interpret this as you can be 55 inches and you can be 72 inches. It'll alter how our graphs look, and I'll show you that in just a little bit. But for now, let's do it with just the greater than and less than symbols. So here's our 55. I'm going to put an open circle. It's open because we just have the greater than symbol. And then we're going to come up here and we're going to count down. So it'd be 79, 78, 76. Wait, sorry. Counting backwards. 79, 78, 77, 76, 75, 74, 73, 72. So here's our 72. We're going to put an open circle here as well because it's just the less than. So we actually have 4 inequality symbols. We've got less than, greater than, less than or equal to, greater than or equal to. So it's when we have the greater than or equal to's, then instead of open circles, we'd have closed circles, which I'll address in a little bit. Now, for this, we've got all our lines in between 8, 9, 60, 61, 62, 63, 64, 65, 67, 77. There we go, approximately. And so the solution to this is all the values in between these two dots. So we draw the line from our circle at 55 to our circle at 72. That is the solution to our high bounce inequality. So showing that it's between the 55 and 72 inches. Okay? All right, so now we want to look at our climathon. So with the climathon, it said that we have to be under 60 inches tall. So that's telling us we can't be 60 inches tall. So H is less than 60 because that shows that we are under 60 inches tall. Now, to take and graph this, we're going to have our number line. I'm going to show a 60 here, and this will be 59, just to get an idea of what we're actually looking at here. Sorry if the screen's a little wobbly. My darling cat is having fun with the computer. So, once again, because we have the less than inequality symbol, we're going to be doing an open circle. There's not the equal to, so that's an open circle. I know it looks kind of closed. And then because it's less than, it's going to be everything to the left. So it's all of those values, all the way down to 0 inches tall, which no one is 0 inches tall. So that wouldn't be the case. But in the terms of this problem, technically that would be part of the solution. Okay. All right. And last but not least, we have the twirl-a-coaster. Let me erase this real quick. All right. So the twirl. Oops. Yeah. Twirl coaster. It tells us on that one that it's a 58 inches minimum, which means the smallest that they can be is 58 inches. So they can equal 58 inches. So H equals 58, and H is greater than 58, which instead of writing these two, oops, you can't see that. Instead of writing 2 inequalities for this, we can instead write it as H is greater than or equal to 58. So like I mentioned earlier, we have this greater than or equal to inequality, same thing, less than or equal to inequality. It works both ways for this. So we have both of those options. So there are 4 inequality symbols. So in cases when it can be that value, we use the equal to part of it. All right, so now comes graphing it. So we graph our line. I'm going to put 60 right here. So here's our 58. Now, like I said, because it's got the equal to, that means we're going to put a nice solid closed dot there. And then because it's greater than, we're going to the right. So you have to think about your number lines and think about what they represent and which direction actually represents greater. So if this were less than, we'd go to the left. If it's greater than, we go to the right. All right? Okay, so now we're going to look at a couple questions based off of these same inequalities and graphs. So hopefully you can look back at your graphs. If not, you can take and use the table to help you as we go through this. So for number 2 on this, it says Han's cousin is 55 inches tall. Han doesn't think she is tall enough to ride the high bounce, but Kieran believes she is tall enough. Do you agree with Han or with Kieran? So let's think. Han's cousin is 55 inches tall. So if we go back to the table and look at the requirements, and we're looking at the high bounce. So high bounce, they have to be between 55 and 72. So this one is kind of an interesting question. We kind of touched on it when we were actually doing that graph. It depends on whether you include the endpoints or not. So that's based on the description. It didn't really tell us whether or not we're including endpoints. So if we include the endpoints, yes, his cousin would be tall enough. But if we don't, then his cousin wouldn't be tall enough. Sorry, I probably should have talked through that. Well, you could see me. So like I was saying, if we include those endpoints, then we have the cousin would be able to take and ride because it includes the 55. Whereas if we don't include the endpoints, then being only 55 inches tall is not tall enough to take and ride on this high bounce ride. So it all depends on how to interpret it. So being as it didn't explicitly say that we have to take and include it, with the way we graphed it, the cousin wouldn't be high enough to take and ride on there. But if we decided that we were going to include those endpoints, then yes, the cousin would be able to. So that's kind of a interesting question to think about. All right, for the next one, it says Priya can ride the Climathon, but she cannot ride the high bounce or the twirl coaster. Which, if any of the following, could be Priya's height? So if we think back, so we've got 59, 53, and 56. If we think back to our table up here, it told us that the high bounce and the twirl coaster, so we've got 55 to 72, somewhere in there, and the twirl coaster, you have to be a minimum of 58 inches. So all going up from there. So 55 is really our low end on this. So the Climathon, she can ride, which just means you're under 60 inches tall. So if she can ride the Climathon, but not either of these two, looking back at our values, which of these values isn't included in the 55 to 72? Well, 59 and 56 are both included in there, so they won't work. 59 is included in both the twirl coaster and the high bounce. 56 is only the high bounce. And so 53 inches, well, that's not 55, which is the minimum. It's also not more than the 58. So 53 inches is how tall she would be. All right, Jada is 56 inches tall. Which rides can she go on? So let's take a look here. She's 56 inches tall. So that's more than 55, so she can go on the high bounce. And let's see, 56, that's under 60 inches, so she can do the Climathon, but it's not more than the 58 inches, so she can only do the high bounce and the Climathon. So I'm going to mark that as H and C down here just so we can see it. H, maybe. And C. Ooh, that was not what I tried to do. And C. There we go. Now, Kieran is 60 inches tall. Which rides can he go on? So if we look, go back up here, we're going to change his to green just so we know the difference. So he's 60 inches tall. So that means he is between the 55 and 72, so he can go on the high bounce. For the Climathon, he has to be under 60 inches tall, so he doesn't count because he is 60 inches, so he's not under it. And for the twirl coaster, he had to be more than 58 inches. 60 is more than 58, so he can also be on the twirl coaster. So high bounce and twirl coaster. So another H here, maybe. H and T for twirl coaster. So those are the two that he can be on. All right, for number 6, it says the inequalities H is less than 75 and H is greater than 74 represent the height restrictions in inches of another ride. Write 3 values that are solutions to both these inequalities. So if we have to be less than 75 but more than 64, what are some of those values? Well, we could be 60 5. We could be 70. Sorry, guys. I know this is taking a while to write. And we could be 74. All of these values would work. Honestly, we can take and pick any value that's between 65, including 65, all the way up to 74, including that 74. So any number between the 65 and 74 would be possible solutions to this inequality right here. Right. So for today, like I was showing, where it's all inequalities and kind of comparing and seeing what values actually fit into the inequality and our solutions. So our key word for the day is solution. Sorry, I had to think of it. So with all of these, we're dealing with these solutions, trying to determine whether they are solutions. So our keyword is solution. So make sure to write that down and submit it to me on Canvas. You'll see the place to do that. Once again, you will get credit for that. If you don't have your workbook, the practice problems are in a PDF, they're in a PDF that will be shared with you. So that way you'll be able to look off those. Once again, when you're taking and doing the assignments, make sure you're making your answers very, very clear. Have it circled, have it boxed, have it highlighted, something. So that way I know exactly what your answer is. So when it comes to grading it, it'll go a lot easier. And then just remember, send me pictures of your practice problems so that I can take and grade those, and you could do it to Canvas, submitting them there, or via my email. And any questions you may have, I'm always available. My office hours are Monday, Wednesday, Friday from 1 to 2. All right. Good luck and happy mathing.